We know this sundial works well at the North Pole, and to make it work at other latitudes, we have to align the gnomon with the Earth's axes. Now, I'll do that here. We're at latitude 45 degrees right now, and that means that I have to tilt the gnomon at an angle of 45 degrees and towards the north. So I'll point this north and estimate 45 degrees. There we are. Theoretically, we have a working sundial. I think you can see the problem. The sun isn't shining on our dial. There's no shadow to work with. The sun's actually shining on the back of our dial. There is a solution to this problem, another design of sundial. We'll take a look at that next. Here is a design of sundial that solves this problem. The gnomon is the edge of this angled card, and the dial lies flat. The sun shines on this surface. A sundial like this must be designed for specific latitudes. For instance, this gnomon is at an angle of 45 degrees, and the radiating lines are no longer 15 degrees apart. They have been drawn to accurately represent the time here at latitude 45 degrees. If you were designing a sundial for latitude 30 degrees, the gnomon would be at an angle of 30 degrees, and the radiating lines would have to be calculated for this latitude. Let's take a look at how to construct a sundial like this one. Any size of a sundial can be constructed. We will construct our sundial from Bristol board, starting with a rectangular piece 14 centimeters by 25 centimeters. Draw lines 1.5 centimeters in from each end. Draw one line 2 centimeters down from the top. Draw a line down the center of the card. Erase the corner construction lines. Next, draw lines radiating from the base at the angles shown. Use a protractor. These angles are correct for latitude 45 degrees north. Label the dial as shown. The gnomon has a base of 12 centimeters and is cut at an angle of 45 degrees. A simple way to make this gnomon is to cut a 12 centimeter square along its diagonal. Tape the gnomon along the center line as shown. A small bracket can be created to hold the gnomon vertically. If you've completed constructing one of these sundials, here's how you set it up. The simplest way to set these up is check the time. It's 10 a.m. right now. Find a nice location, a sheltered location in your house where the sun comes in on a windowsill or on a table. Set your sundial, rotate it until the shadow from your gnomon indicates 10 a.m. and then pin it there. Piece of tape on each side will hold it down, and as the day progresses, as the Earth rotates, the shadow will change and indicate the time. This next sequence shows the shadow moving from 2 p.m. to 6 p.m. As the Earth turns, we can watch as the shadow progresses, moving towards 3 o'clock, 3 p.m. moving on past 3 p.m. to 4 p.m., 5 p.m., and 6 p.m. The last number on our dial. Now, the gnomon, this shadow casting surface here, must point north. And in fact, when you've set it using your clock, it is pointing north. So it's indicating north for you as well. It's like a compass. If you had your sundial set up outside and came out at night on a clear evening and sighted along the top edge of the gnomon, you would find that it was pointing at Polaris, the North Star. This sundial is designed for latitude 45 degrees, but it will work reasonably well at any latitude between 40 degrees and 50 degrees north. Dimensions for different latitudes can be found at our website, hylaroad.com. This is a sundial hour line angle calculator. Enter your latitude, click Calculate, and the angles are displayed. This calculator is in the Projects area of our website. You can find other sundial calculators on the internet.